This podcast is brought to you by the Fountain Bridge. When we think about humanity's greatest predators, we usually picture like teeth or claws.
Right, the classic apex predator.
Yeah, exactly. We think of lions or bears or sharks. But if you look at the actual numbers, the most dangerous creature on Earth, doesn't have claws at all.
No, not at all.
It weighs about 2 milligrams. It has wings. And today, on April 24, 2026, which is World Malaria Day, by the way, the World Health Organization is they're scrambling to outsmart it.
It's a really fascinating arms race right now. The WHO just launched their campaign slogan for this year, which is driven to end malaria. Now we can, now we must.
Catchy.
Right. And it's a very deliberate choice of words, I think, because the science has evolved so rapidly in just the last few years that we actually can envision an end to this.
Which is wild to think about considering the stakes, In this deep dive, our mission is to really unpack this massive public health effort.
Yeah.
We're talking about insects of the Calicidae family.
The mosquitoes.
Mosquitoes, yeah. And, we want to look at the global strategies, the things you can do at your own house, and the new science that's basically rewriting the rules. Because these bugs, they are responsible for 17% of the global burden of communicable diseases.
It's staggering.
Yeah. And malaria alone claims over 600,000 lives every single year. And the truly heartbreaking part of that statistic is that the vast majority of those victims are children under 5.
Over 600,000. It is daunting. But, the critical context here is that while those numbers are immense, we aren't defenseless.
Right.
In fact, public health prevention is our absolute sharpest tool, and we are completely rethinking how we use it.
So let's get into the mechanics of that. Because to understand how we fight back, we first have to look at the massive global goals the WHO has set and, why achieving them is so incredibly difficult.
Definitely.
They have these specific vector control targets for the year 2030.
Right. Yes, they're aiming for a 75% reduction in mortality and a 60% reduction in case incidence compared to the 2016 levels. Plus, they want to prevent epidemics in all countries.
Okay, those are very ambitious numbers.
Extremely ambitious. But what usually surprises people is that achieving this, it isn't simply a matter of, manufacturing more medicine or handing out millions of bed nets.
Wait, really? Because that's kind of all you ever hear about.
Right. But the primary obstacles standing in the way of those 2030 targets are actually environmental and social.
Okay, give me an example of how, the environment is actively fighting us.
Well, think about rapid, unplanned urbanization. When a city expands faster than its infrastructure, entire neighborhoods just spring up without reliable piped water.
Oh, I see.
So the people living there, they're forced to store water in open containers or cisterns inside their homes.
Which is essentially building a luxury nursery for a mosquito.
Precisely. And then add inadequate waste management to that. Discarded tires, plastic containers, they collect rainwater and become thousands of microhabitats.
Just tiny little swimming pools everywhere.
Exactly. Then you have shifting land use, like deforestation for agriculture, which alters local ecosystems and brings humans into closer contact with wild mosquito populations.
Man.
And, of course, we can't ignore climate change. Warming temperatures mean mosquitoes can now survive at higher altitudes and latitudes, and their metabolic rates actually accelerate in the heat, meaning they breed faster.
Oh, and aren't they also, mutating to survive the chemicals we spray?
Yes. Insecticide resistance is a massive growing hurdle. The mosquitoes that survive the spray, they pass those survival genes on to the next generation.
So if the landscape itself is actively helping the mosquitoes breed, the health department is essentially bringing a stethoscope to a knife fight.
That's a good way to put it.
You can't ask a doctor to fix the city's plumbing. It's like trying to bail out a leaky boat with a teacup while your town's urban planners are actively drilling more holes in the hull.
That exact realization is what forced a complete rewrite of global public health policy. Health departments cannot do it alone. The WHO recognized this and created a strategic framework that completely rethinks who is responsible for vector control. It's essentially the policymaker's playbook.
Let's open that playbook then, because it sounds like you're trying to orchestrate a massive government overhaul just to kill a bug.
It is a huge overhaul. The framework outlines 3 essential enabling factors that a country absolutely must have in place before they even attempt the actual strategy.
Okay, what's the first one?
First, you need strong, centralized country leadership. Second, advocacy, resource mobilization, and partner coordination, basically, getting everyone aligned and, funded.
And the third one?
Regulatory, policy, and normative support.
Okay, pause. Normative support. What does that actually mean in the real world? We're talking about insects here, not tax law.
Right, it sounds bureaucratic, but it means making mosquito defense a legal and cultural standard. You can invent the best mosquito trap in the world, but if the Ministry of Housing isn't legally required to mandate window screens in new apartment buildings,
Oh, wow.
or, if agricultural laws allow farmers to leave stagnant irrigation ditches completely unchecked, you've already lost. Normative support means rewriting the rules of society so that everything we build naturally resists the vector.
Okay, that makes sense. So once a country has that foundation, the leadership, the money, the laws,
Yeah.
what is the actual ground game?
The ground game is built on 4 pillars. Pillar 1 is intersectoral action. This is the big shift we were just touching on. The health sector has to collaborate with non-health sectors.
So like ministries of housing, agriculture, water, and urban planning all sitting at the same table.
Yes, because if they work together, they design cities that are just naturally hostile to the mosquito.
It's fascinating that an urban planner, or like a sanitation worker, is effectively on the front lines of malaria prevention just as much as a doctor is.
They really are the first line of defense. Now, Pillar 2 is engaging and mobilizing communities. This shifts the power to the locals.
Got it.
Pillar 3 is enhancing vector surveillance and monitoring, so catching population spikes before an outbreak even happens. And finally, Pillar 4 is scaling up and integrating tools, meaning you don't just rely on indoor spraying, you combine it with bed nets, spatial repellents, and environmental management for maximum impact.
Okay, so if Pillar 2 is all about engaging the community, let's take this out of the WHO boardroom and bring it right into our listeners' own backyards. What does community participation actually look like when you aren't, a government official?
It looks like harnessing local knowledge. Instead of a community just passively waiting for a government truck to come by and spray a neighborhood, the locals themselves are trained to conduct community-based surveillance.
Makes sense. They know the area best.
Exactly. They know where the abandoned lots are. They know which drainage ditches flood. It's really about collective ownership of the local environment.
And what about physical changes? If I'm listening to this right now, what are the literal physical things I can do to my house to disrupt this?
The research highlights 3 highly practical changes households should focus on. Number 1, improve your domestic water supply. If your home has a reliable piped water connection, you eliminate the need for open water storage inside, which removes a prime indoor breeding ground.
Simple enough.
Number 2, install physical screening on all entry points. Doors, windows, eaves. Keep them physically separated from your living space. And number 3, vigorously eliminate any standing water around your property.
And this all comes back to their biology, right? Because they need water to grow.
Absolutely. The mosquito's life cycle has 4 stages: egg, larva, pupa, and adult. The first 3 stages, egg, larva, and pupa, are entirely aquatic.
Really? Entirely?
Yes, they absolutely require water to survive. If you dump out that tire swing or, clear out that clogged gutter, you are physically breaking their life cycle. They dry out and die before they ever sprout wings.
But realistically, humans have to go outside. And the second you leave that screened-in porch, you are back on their turf. There is so much marketing out there about personal protection. What does the actual science say about hiding our scent from them out in the open?
Researchers have tested this extensively, looking at chemical efficacy on the skin, and the data strongly supports DEET as highly effective, providing protection for up to 6 hours.
Let me ask about DEET, because people use it all the time without knowing what it actually does.
Ooh.
Are we just poisoning the mosquito when it lands on us?
Not at all. DEET doesn't kill them, it effectively blinds them.
Blinds them.
Well, olfactorily. Mosquitoes find you by smelling the carbon dioxide you exhale and the lactic acid on your skin. They have these highly specialized olfactory receptors on their antenna.
Okay.
DEET works by jamming those receptors. It scrambles their ability to process the scent of a human. To a mosquito, a person covered in DEET basically just disappears into the background noise of the environment.
That is incredibly cool. We're basically wearing an invisibility cloak.
Essentially, yes. Now, if you prefer an alternative to DEET, picaridin, specifically at a 20% concentration, is scientifically proven to be just as effective at jamming those receptors.
Good to know.
And for a plant-based option, oil of lemon eucalyptus, or OLE, also shows high efficacy in clinical trials.
Okay, so DEET, picaridin, and OLE are the gold standards. But what about all the gimmicks? You see these ultrasonic mosquito bracelets being sold online, or people swearing that taking vitamin B supplements makes your blood taste toxic to them. Are those doing anything at all?
The research is completely unequivocal on this. Dietary supplements like vitamin B are completely ineffective. There is zero evidence they alter your attractiveness to a mosquito.
And the ultrasonic bracelets, the
Yeah.
ones that supposedly emit a high-frequency sound to scare them away.
Also entirely ineffective. In fact, laboratory tests have found that those ultrasonic devices might actually slightly increase mosquito attraction to the wearer in some cases.
You are kidding. So you buy this piece of plastic to keep them away, and you're essentially walking around wearing a dinner bell.
Pretty much. You really want to stick to the scientifically proven repellents. You want to jam their radar, not announce your presence.
Wow. So we've talked about modifying our cities through urban planning.
Wow.
We've talked about modifying our homes with screens and our skin with DT. But the final frontier of this fight, as I understand it, is modifying the mosquito itself.
Yes.
And to do that, you have to deeply understand how they operate.
This is exactly what we thought. Near a solution if we don't understand the organism's fundamental biology.
Right.
For example, basic research tells us that Anopheles mosquitoes, the specific genus that transmits malaria, have some very distinct habits. They generally only fly about 1.2 miles from their larval habitat, and they strongly prefer to bite late in the evening or in the middle of the night.
So once you know that, you aren't just spraying randomly across an entire continent. You know exactly where their home base is, and you know they work the night shift.
Precisely. You target the interventions. But that deep understanding of mosquito biology has led to something even more remarkable: biological warfare.
Oh, this is the wild stuff.
There are two massive cutting-edge innovations happening right now. The first involves a trial run by the World Mosquito Program in Yogyakarta, Indonesia. They used a naturally occurring bacterium called Wolbachia.
Okay, I've heard of this. You infect a mosquito with a bacteria to stop a virus. That sounds counterintuitive. Are they making the mosquitoes too sick to fly?
It's more elegant than that. Wolbachia is a bacterium that naturally exists in about 60% of insect species, but usually not in the Aedes aegypti mosquito, which is the one that transmits dengue, Zika, and yellow fever.
Okay.
When scientists introduce Wolbachia into the Aedes aegypti, the bacteria acts like a massive resource hog inside the mosquito's cells.
A resource hog.
Yes. Viruses like dengue need certain nutrients like cholesterol inside the mosquito's cells to replicate, but the Wolbachia bacteria consumes all those resources first. The virus essentially starves. It can't replicate. That means the mosquito cannot transmit the disease to the next human it bites.
That is brilliant. So what actually happened in the Indonesia trial?
They ran a randomized controlled trial, releasing Wolbachia-carrying mosquitoes into specific clusters of the city. As those mosquitoes mated with the wild population, they passed the bacteria to their offspring. It spread naturally.
And the results?
The result was a 77% drop in dengue incidence in the treated communities compared to the untreated areas.
77%. You aren't just putting a dent in the numbers, you are fundamentally collapsing the disease's ability to exist in that city.
It is a massive breakthrough. And the second biological innovation is even more advanced, moving from bacteria to direct genetic engineering.
Okay, brace me.
It's called gene drive technology, and it's currently seeing active research with field trials planned in Africa to target the malaria-carrying Anopheles mosquitoes.
Gene drives. That genuinely sounds like science fiction.
Yeah.
How does that differ from just normal genetic modification?
It's all about forcing inheritance. Normally, in standard Mendelian genetics, if an organism has a specific gene mutation, it only has a 50% chance of passing that gene to its offspring. It's a coin flip.
Right.
If that mutation makes the mosquito sterile or unable to carry malaria, natural selection will quickly weed it out because those mosquitoes won't reproduce as effectively as the wild ones.
Because nature favors the healthy, dangerous mosquito. So how do you beat the coin flip?
By using a gene drive, which typically utilizes CRISPR gene editing technology, you engineer the mosquito's DNA so that it actually copy-pastes the altered gene onto the other chromosome.
Wait, it copy-pastes it.
Yes, it overrides the normal rules of reproduction, guaranteeing that nearly 100% of the offspring inherit the modification. You release a small number of these engineered mosquitoes, and within a few generations, the trait sweeps through the entire wild population.
So you could theoretically release a handful of mosquitoes engineered to be like sterile females, and within a year, the entire local population just breeds itself out of existence.
That is the goal. You are using the vector's own reproductive drive to cause a localized extinction of the disease-carrying population.
That is incredibly powerful. But obviously, I mean, rewriting wild DNA and releasing it into an ecosystem is going to make people nervous. I have to imagine the regulatory hoops for this are just astronomical.
They are, as they should be. The policy briefs highlight that there are significant ecological and social implications. What happens if the gene jumps to another species? What role does that specific mosquito play in the local food web?
Right. Unintended consequences.
Exactly. There is a massive need for comprehensive, transparent frameworks and deep community engagement to ensure there are no unintended ecological consequences. The promise is substantial, but it requires extreme caution.
Which is completely fair. But it's not just us deploying new science, right? The diseases themselves are fighting back. And there's a brand new development the WHO just announced today for World Malaria Day regarding how we test for malaria, and the biology behind it is wild.
You're talking about the new rapid diagnostic tests. The parasite is adapting.
Yes. So for years, the standard rapid tests for malaria have looked for a specific protein produced by the parasite, known as HRP2. If the test detects HRP2 in your blood, boom, you have malaria.
Simple enough.
But research has discovered that in 46 countries, the malaria parasite has literally evolved to drop the gene that makes that protein.
It is a perfect, terrifying example of evolutionary pressure. The parasites that produced HRP2 were caught by the tests, the patients were treated with antimalarials, and those parasites died.
Yep.
But the rare mutant parasites that didn't produce the protein, they slipped past the tests. They survived, reproduced, and now they are taking over.
They figured out how to become invisible. In the Horn of Africa, up to 80% of malaria cases were returning false negatives because the parasite was hiding. It's like a criminal realizing the bank security guards are only looking for people wearing specific red name tags.
So the criminal just takes off the name tag and walks right through the front door.
Exactly. But today, the WHO just pre-qualified a completely new set of rapid diagnostic tests that target a different protein one called PFLDH. And here's the kicker. This is a protein the parasite actually needs to survive. It can't easily shed it without crippling itself. So we essentially upgraded the bank security from checking name tags to using facial recognition software. They can't hide anymore.
I love that analogy, and it perfectly highlights why this fight requires constant vigilance. We cannot rely on the tools of yesterday to fight the diseases of tomorrow. We have to adapt faster than they do.
We really do. So as we wrap up this deep dive, let's just look at the incredible scale of the journey we've just taken. We started with the WHO's ambitious 2030 targets, aiming to slash mortality by 75%.
Right.
We saw how achieving that requires a complete paradigm shift, using those three enabling factors to deploy a multi-sector strategy where housing ministers and sanitation workers are fighting alongside the doctors.
And we zoomed in to see how local communities are taking ownership of their space. Right down to you, the listener, fixing the screens on your windows, slathering on the DEET to jam the radar, and dumping out the standing water in your backyard to physically break their aquatic life cycle.
And then we went all the way down to the cellular and genetic levels, understanding the flight patterns of an Anopheles mosquito, deploying Wolbachia bacteria to starve the dengue virus in Indonesia, navigating the complex science of gene drives to force an extinction trait through a wild population in Africa.
Incredible stuff.
And finally, upgrading our diagnostics to catch a parasite that literally evolved an invisibility cloak. When you look at the sheer ingenuity of all that, it really gives new meaning to the phrase, now we can, now we must.
It really does. And if I can leave you with a final thought to ponder. For centuries, the engines of human progress, our agriculture, our rapid urbanization, our global travel, they have inadvertently created the absolute perfect world for mosquitoes to thrive and spread disease. Unknowingly, we built their utopia.
We were our own worst enemy.
But not anymore. For the first time in human history, we are using our progress to consciously design a world where they cannot thrive. We are engineering our cities, our homes, our immune responses, and now even the DNA of the mosquitoes themselves. So the next time you are outside in the evening and you hear that high-pitched buzzing in your ear,
Oh, I know that sound.
you should wonder, are you hearing a wild pest or are you hearing a genetically modified organism deployed to save millions of lives?
Now that is something to think about. Thanks for joining us on this deep dive.